Good morning, students. Today we are going to read the DC Motor in the topic of electromagnetism 2 in the subject of physics O levels. So concentrate yourself. Here we are going to start. A coil pivoted in a magnetic field. Wind several turns of the wire round a cork and hang it from a clamp like this between the poles of the magnet as shown in the figure. Pass a current briefly through the coil. What happens? Does the coil turn the opposite way if you reverse the current? This is the question. So this twisting movement is used in the electric motors and in moving coil ammeters and voltmeters. So this is the phenomena. This is the technique which is used in the ammeters and the voltmeters. There are two ways to find the direction of the rotation in the diagram. Number one, use Fleming left-hand rule for each side of the coil. And this is the Fleming left-hand rule, which you will learn in this topic later. The second way is find which end of the coil becomes a north pole. This end will be attracted to the south pole of the magnet. Apply both these methods to the diagram and check that they give the same result. Okay, here is the main topic now. The simple electric motor, that is direct current motor. In short, it is called DC motor. The coil in the moving coil galvanometer rotates until the plane of the coil is perpendicular to the magnetic field. That is, until the south pole of the coil is opposite to the north pole of the magnet. So the moving coil galvanometer will be rotated until the south pole of the coil is opposite to the north pole of the magnet. If some means can be found to change the direction of the current at this point, the polarity of the coil will change and it will continue to rotate in a clockwise direction or in a anti-clockwise direction. Normally it is rotated in the clockwise direction. Its momentum will carry it slightly beyond the rest position, and the pole which is now a north pole will be repelled by the north pole of the magnet. Thus, for continuous motion, it is necessary to change the direction of the current in the coil after every half revolution. So the technique is, whenever the north pole of the coil will be against the north pole of the magnet, these two poles will repel each other. Thus, the continuous motion is necessary. So the change of the direction of the current in the coil after every half. So when the other end will be opposite to the north pole of the magnet, so it will continuously to rotate. When the plane of the coil is perpendicular to the magnetic field, this is achieved by connecting the ends of the coil to a split ring commutator. So this is the device which is responsible for the continuous movement. This split ring commutator consists of two half cylinders of copper attached to a cylinder of the insulator, so that there is a gap between the copper at both top and bottom. And you will see the figure later. Each end of the coil is connected to one half of the copper cylinder, arranged so that the split in the commutator is perpendicular to the plane of the coil. Thus, when the coil is vertical, the split in the commutator is horizontal. The current is led in and out of the coil by carbon blocks or strips or metal. These are known as the brush. And here you can see, here are the carbon brushes. This is split ring commutator. This is magnet, north pole and south pole, and this is the rotation which is produced due to the in and out current in the carbon brushes. Here is the commutator, here is the insulator and copper cylinders, two half cylinders are there. Okay, after traveling round the coil, the current passes through the other half of the commutator, so and back to the battery. use Fleming's left hand rule for the wire that is near the north pole of the magnet. And here is the Fleming's left hand rule. This finger directs in the direction of the current, this finger into the direction of the field, and this thumb into the direction of the movement of the wire. That is, the commutator makes sure that the whichever wire in the diagram is nearest the north pole, it always has current moving out towards us. So this is the point to remember. The commutator makes sure that whichever wire is in the diagram is nearest the north pole, it always has current moving out towards us, and so the wire keeps turning clockwise. So this is the technique how a DC motor rotates. If either the battery of the poles of the magnet were the other way around, the coil would rotate anti-clockwise. The brushes are usually made of the carbon and held against the commutator by spring. So this is the technique. Look here, current flows in right and out of the left. So current in to the right and out from the left. And when this apparatus comes into this horizontal position, there is no current. But again, when it comes into the vertical position, current flows in from the right and out from the left. And this is how this moves in a clockwise direction. In a motor, a coil carrying a current rotates between the poles of the magnet. The coil is kept rotating continuously by the use of the split ring commutator. This causes the direction of the current in the coil to reverse, so that the forces continue to act on the coil to keep it turning. Figure below explains the action of the commutator, and this is the figure that is coming now, and that will explain you more. Look now, a current flows into the coil through the commutator, so that there is an upward push on the side A and downward push on the B. Figure A, the coil rotates in a clockwise direction. So look now. So this is figure A. So on the A portion, upward force will be applied, and on B, downward force will be applied, and this will rotate in a clockwise direction like this. This is rotating in a clockwise direction. So further look now. When the coil reaches the vertical position, no current flows through the coil. The coil continues to rotate past the vertical due to its own momentum. Figure C. So look now. Due to its momentum, it will continue to move. But in this position, there will be no current. So this is the position C. Whenever it comes into the vertical position, there will be no current. But due to momentum, it will continue to move. So A end will come to here and B end will come to here. So further look now. Now side A is on the right hand side. The direction of the current flows into the coil has been reversed. Figure D. So look now. So this is the figure D. Now A is coming to this side and B is coming to this side. So current is reversed now. Side A is pushed down and side B is pushed upward. The coil continues to rotate in a clockwise direction. So look now. At A position, there was upward force on side A and downward force on side B. But now in C's position, you can see that on A is downward force is applying now, and on B upward force is applying now, and this is the way that it will rotate, continue to rotate in a clockwise direction. A DC motor works only on a direct current like the one supplied by a dry cell. Commutator is a device for reversing the current. Direction of the current flow into the coil every half revolution. So whenever the half revolution is done, the commutator actually reverses the current. The brushes are arranged so that when a coil is passing through the vertical position, the two halves of the split rings are just on the point of the changing contact from one brush to another. When used in this way, the split ring is called a commutator or current reverser. So whenever it comes into the vertical position, there is no current and current is reversed. And so the end on which previously upward force was applied, when it comes to the other end, so downward force was applied on the same end. The reason for using magnetic circular pole is to have a uniform magnetic field for the coil. Even with the rotation, the distance between the arms and the poles is a constant. The purpose of using the split ring commutator is to allow the coil to rotate in the same direction, that is clockwise direction, by reversing the current through the arms of the coil every half turn. So this is the purpose of the split ring commutator. So this was the lecture, students, the DC motor. I hope so this will be much more easier for you to understand now. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.